Okay, guys, I just wanted to show you some of the stuff that we did on Saturday. Basically, what I did is I took a real quick recording of us shooting um, the foam balls, and I ran the software that we use when we're teaching physics that basically maps out the projectile. So, what I did is I analyzed the ball as it was in flight. It doesn't matter that the video is moving because I'm tracking the differences between position and time. And so I only did it for 6 balls. But as you can see, I'm tracking position versus time, which helps me to calculate the velocity and everything. And so this is what the video looks like, and this is what we tracked. And I didn't do all of them. I didn't need to, because what I found out, which is kind of what we suspected in the beginning, anyways. Um, these quadratic curves are the actual position versus time. It is not. It's to scale, but it's misleading. But as you can see, this ball is higher than this ball. This ball is lower. This one is lower. These are the peaks or the maximum heights of each ball. Now, these straight lines or somewhat straight lines, that is actually going to be the velocity of the ball. And so, well, the slope of this line is somewhat of the velocity of the ball. And then here, of course, is just the raw data that spans through each ball. So I collected the data. So this would be the first ball, this would be the second ball, third ball, so on and so forth. Then what I did is I took that information and I plugged it into a spreadsheet like this. And then I did a little bit of math. So this is the first ball, this is the velocity. Here's the second ball, here's the X and Y coordinates, and then the vector calculations of the actual velocity. So I have the X and Y components of the velocity in inches, and then I converted that to the overall velocity of each ball into meters per second. Now, what I found from that is that this is the velocity of the first ball. So when that thing leaves the shooter, that first ball is coming out at about 10 meters per second. The second ball, which is this one right here, that's coming out of the shooter at about 8.29 meters per second. And as you can see, the third one is 8.42. The fourth one is 9.38, and so on and so forth. Now, the reason these are dipping down, air resistance. So that was one of the things that Dan talked about was, are we considering drag or air resistance? I thought that it wouldn't be that strong, but as you can see, it slows the ball down quite a bit overall. However, this is the vector velocity, so I gotta think about that for a second because it might go back up. But anyways, as you can see, we're coming out of the shooter at different speeds. And so the next step is what we're already looking at, is how do you have a more consistent velocity coming out of the shooter.